Well, hello guys. Welcome to Ask IITian. My name is Gaurav Yadav. I hope you all are doing well, right? So, guys, today we'll discuss the chapter Symmetry. Okay, just let me share my screen. So, yeah, Symmetry. First of all, we'll discuss what is the meaning of symmetry. Okay, what do you mean by symmetry? The picture shown in you on your screen, right? If you just draw a line here, you will think that the two images are the images one and image two are all equal, right? Or are mirror reflection. So yeah, today we'll discuss the introduction of symmetry, lines of symmetry for different regular polygon and triangle of course. And we'll do seven questions. Okay. First of all, we'll discuss what symmetry is. If we take a real life example, right? For example, the t-shirt you are wearing, the t-shirt you are wearing, this is your round neck. Guys, your t-shirt, your shirt are all symmetrical in nature, right? For example, suppose this is your t-shirt, okay? Suppose this is your t-shirt, okay? You will observe that if you draw a line in middle of the t-shirt like this, right? And if you just revolve one part onto the other, you will observe that it perfectly coincide on the other. Like the same way your jeans, your pants, your trousers, your shirts all have your symmetry. So this is basically is your line of symmetry. Another example we can take, for example, an isosceles triangle is there, right? If you draw a line, you know what isosceles triangle is, having two sides of equal. If you draw a line in the middle of it, right, you will find that this one part will coincide the second part on this rotation. On or it will have a mirror image, right? If you think that if you observe that if you line of symmetry acts as like a mirror, okay, you will have a mirror image. So this is what the line of symmetry. So what the question is, what does the line of symmetry do? Right? It basically divides the figure into two parts such that the whole both two parts are of equal shape and equal size. Right? Okay. We'll discuss simple examples. So mathematically, symmetry means that one shape becomes exactly like another when you move it in some way, or turn it, or flip, or slide, right? For two objects to be symmetrical, they must be of same size and shape, like what I have told you. with one object having a different orientation from the first. There can also be a symmetry in one object of the space. For example, if you think about the alphabetic object, alphabet means alphabet A, and it has a line of symmetry where if you draw a line in middle, you will find out that your line will act as a mirror, okay, and your it has cutted in your A in two parts so that the two parts are all both equal, okay. For example, D, this is your vertical line symmetry, vertical line symmetry. Your D alphabet has your horizontal line symmetry, okay. If you just if you just put the first part into a second, it will just overlap or coincide, right? So it has horizontal line symmetry, okay. Your word H, your alphabet H has both vertical line symmetry and your horizontal line symmetry, okay. Both horizontal line symmetry and vertical line symmetry. Guys, your word G has no line symmetry, no line symmetry. Also, your Z has no line symmetry. Okay, so yeah, this is what. So this is, I think you have got the point what line of symmetry means, right? Uh, these are your line of symmetry. I think you all have got the point, right? So lines of symmetry for different regular polygons. We are discussing regular polygons. It means they will have equal angles. Okay. So our is a regular polygon of four sides. It has four lines of symmetry in four sides. A regular pentagon. We are discussing equilateral triangle, square, regular pentagon, and regular pentagon. Okay. So let us say what square. We are discussing for you line of symmetry. The square. You all know square. Square has all four sides. So if you take your line of symmetry as a vertical, the first part will overlap to another part. Okay, so it has a line of symmetry. Also horizontally, and yeah, vertically also, sorry, diagonally also, that this part will overlap to diagonally to another part. So basically, it have four lines of symmetry. So guys, square has four sides and all angles are equal. It means it's a regular polygon of four sides, so it has four lines of symmetry. Triangle. Now we are discussing for you equilateral triangle. Equilateral triangle. Okay. So if you think cut equilateral triangle from the middle and from this vertices to that opposite side like this way. So it has three lines of symmetry. Okay. Basically, that point, your point is your centroid. Now let us discuss the pentagon. If we just take a vertical line symmetry, right, you will find that the two parts will overlap each other, right? Also, you diagonally, it will be more clear to uh, have this figure, right? So you one line, one, then you from each vertices, from each vertex to opposite side, just draw a line. You will find that there will be how much line? There will be five lines of symmetry. And similarly, regular hexagon, there will be six lines of symmetry. Okay, the diagram is not possible. Okay, from each vertices will go to opposite side. Okay, I'm just drawing, but the diagram is not as proper as shown here. Okay, so there will be what in case of pentagon, five. Pentagon has five sides. Okay, five lines of symmetry also. Now comes hexagon. It will have vertical one, your horizontal one, and from each side. This one also. Okay, from each side to each one. So this will have how much hexagon will have six lines of symmetry. Just calculate the number of sides a regular polygon has, then it will have that much uh, lines of symmetry, right? For example, square, it has four sides, four equal sides, so it has four lines of symmetry. With a triangle, three, so three lines of symmetry. Pentagon has five, so five lines of symmetry, and hexagon has six lines of symmetry. This is what lines of symmetry means, guys, right? We'll do question based on it. A triangle like we have already discussed. Okay, so triangle can be your axis-based, scalar, and equilateral triangle. Equilateral triangle we have already discussed. In case of equilateral triangle, there will be how much lines of symmetry? Three lines of symmetry. This is a line of symmetry. They will just overlap right on this nozzle because it has a central. So equilateral, three lines of symmetry. Okay. What in case of axis triangle? Only a single line of symmetry will be there. Okay. If you just overlap first part into second, that part will just overlap, and that is basically a similar part. Okay. So as soon as the space triangle, one line of symmetry. What in case of scalar? A scalar triangle is basically a triangle having unequal sides. So A, B, C are have these are unequal sides, so there will be no no line of symmetry. You cannot draw a line of symmetry in case of scalar triangle. Okay. So guys, questions are there for you. State the number of lines of symmetry for the following. Right, an equilateral triangle. So basically, an equilateral triangle will have how much lines of symmetry? Three lines of symmetry we have already discussed, right? So first part, equilateral triangle will have three lines of symmetry. We have already discussed. Then the second part. Second part, isosceles triangle. How much line of symmetry? One line of symmetry. We have already discussed. As okay. One line of symmetry. A scalene triangle. Third is it has no line of symmetry. We have already discussed this now, right? Fourth is your rectangle. Guys, tell me how much, how many lines of symmetry will just a rectangle will have, right? So solutions, if a line divides a figure into two parts such that when the figure is folded about the line, the two part of the figure coincide. This is what a line of symmetry means, right? Line of symmetry is basically a line to which if you just fold it from one part, the that will overlap or coincide to your second part. Okay, so that is known as the line of symmetry. The particular triangle has three lines of symmetry. Okay, so you access case triangle has one line of symmetry, and thus a scalar triangle has no lines of symmetry. Okay, so a scalar has two lines of symmetry. I will just show you how. A rectangle, a rectangle will have only two lines of symmetry, a horizontal one and a vertical one. Okay, this is what rectangle is. Each angle is 90. Okay, so yeah, it will have a horizontal line of symmetry, sorry, a vertical line of symmetry and a horizontal line of symmetry. It will not have any diagonal symmetry. Okay, so rectangle has two lines of symmetry. So it will have how much? Two lines of symmetry. Guys, next is your rhombus. Okay, so yeah, rhombus has two lines of symmetry. Why? How? Let me show you here. Rhombus having each side equal, and your diagonals are 90 degrees, right? So it will have your lines of symmetry diagonally. Okay, so it will have two lines of symmetry. The next part is a parallelogram. We'll cover all the figures we have studied now about the lines of symmetry. Okay, parallelogram, guys. How many symmetry of line symmetry a parallelogram has? Let me just show you that parallelogram has no line of symmetry. It has no lines of symmetry, right? Because if you just try have a paper cut it like a parallelogram, right? Try to work from one side to another. You will find that it has no line of symmetry. Okay, then a quadrilateral. So yeah, not any specific quadrilateral. Quadrilateral, no any square has four lines of symmetry. Square has four lines of symmetry. Parallelogram has no line of symmetry. Okay, if you just look that you just take a paper, cut it like a parallelogram, you will find that no lines of symmetry is there because you can't go from one part to another and it will not coincide. Okay, and yeah, so a quadrilateral has no line of symmetry because not any specific quadrilateral is given. Okay, a regular pentagon has five lines of symmetry. We have already discussed. A regular hexagon has six lines of symmetry. We already have discussed. Circle and do semicircle. Okay, so we will discuss. Quadrilateral has no line of symmetry. So not any specific quadratic is given. So you can suppose that if this is your quadratic again, so it will have no line of symmetry. Guys, how many lines of symmetry does your circle has? Let me just your circle. How much line of symmetry the circle has? If you think about it, you will think that okay, your diameter, your horizontal one, then you any line passing through center that is along the diameter, you will find that infinite number of symmetry can be there. Infinite line of symmetry, right? Because a circle is such a figure which is equidistant from its radius, right? So any line of symmetry just passing through its center, you will find that infinite numbers of line of symmetry can be there. Next is semicircle. Semicircle has only one line of symmetry. Let me just show you. This is what your semicircle is. If you just take the center and a line of symmetry, this one, you will find that if you rotate one part to another, it will form just a mirror image. Okay, so semicircle has one line of symmetry. No other line can have this type of property. Okay, So yeah, this is what we have discussed, that equilateral has three lines of symmetry, isosceles triangle has one line of symmetry, scalar has no line of symmetry, rectangle has two lines of symmetry, by having examples of it, right? So guys, question is there for you. Question two is there for you. What other name can you give to the line of symmetry and isosceles triangle? So if isosceles triangle is there, you know that in isosceles triangle, how many lines of symmetry are there? Only one. Isosceles in the triangle having two sides equal. Only one line of symmetry will be there. If you fold one part to another, it will just overlap or just coincide, right? Your line of symmetry will act as a what? Will act as a mirror. Okay. So what other name can you give? What is this? What is your line of symmetry? You can also name it as your altitude, right? It will walk as an altitude of isosceles triangle. Okay, this is what question wants. And a circle, guys, you know that a circle has infinite numbers of lines of symmetry passing through the center along the diameter. Okay, so this is what all along the diameter. Circle has infinite lines of symmetry. You can just fold, you can just draw a line passing through center, right? And just fold the one part into another. You will find that it just overlap, right? So there can be infinite lines of symmetry, and all are can what other name can be given? Diameter. Or lines all along its diameters. Okay. So question is, a three-dimensional shape is what? Three-dimensional shape is what? Question is there. First part none of these, second part 2D. Obviously no, because three dimension is given, not 2D means you have two dimensions. Okay, plane, no, plane is a 2D figure. Fourth is solid. Yes, solid is your three dimension shape. Your three dimensional shape. Okay, the most important part of a map is what? The most important part of a map is scale, right? If you draw a map, your scale factor, right? Your scale factor, that from what to what you are doing scale, that into 1 centimeter. You can just draw 1 centimeter equal to your 1 kilometer. This is what your scale means, right? Like if you are drawing a map, right? And you are showing that distance in kilometer. So you are taking the 1 centimeter as your 1 kilometer. So this is what scale means. You are scaling the map, okay? What is the base of hexagonal prism? So as it name suggests, hexagonal prism is what? So hexagon. What prism means? Prism is a shape which have what prism is? Prism is a shape which have its top and base same, right? For example, this figure, or you can take your Rubik's cube. Rubik's cube is a prism-like shape. Why? Because it has square face, square top and square base. Okay, square face. So yeah, the cube is a cube. can act like a square face prism. Okay. So yeah, hexagonal prism means it is basically a prism. Hexagonal prism means it will have top and the base as hexagon. Okay, identical bases. That is, top is same, the base is same. So yeah, guys, this is what we have discussed in this session for your symmetry. Okay, just keep learning, guys, and keep practicing. Okay, try to do as many as questions you can do from your reference book, from your NCERT book, and we'll meet you soon in your next session. Thank you, guys.